like to welcome all the distinguished guests for the 2018 10 Prize in Sustainable Development. Let's all give us a round of applause to welcome our distinguished guests. 请大家鼓掌，欢迎我们今天的与会来宾。那我们现在，让我们以热烈的掌声来欢迎今天的与会来宾，请各位来宾挥手致意。首先，我们介绍的是。Now let us welcome the President of National Zhongxin University, President 薛富盛。请大家热烈鼓掌，谢谢。请坐。Professor Shen Yong from Department of Soil and Environmental Science here in National Zhongxin University. Professor Zhuang Bingjie from National Zhongxin University. 以及我们这次的得奖者。The 2018 10 Prize Awardee Laureate of Sustainable Development, Dr. Veerabhadran Ramanthan. 欢迎我们的得奖者，以及欢迎中央研究院院士 Academician of Academia Sinica, Dr. 刘少成。And the Vice President of National Zhongxin University, 杨长贤副校长，以及我们的唐奖的基金执行会执行长 ，The CEO of 10 Prize Foundation, 陈正栓执行长。非常感谢各位来宾。那我们再一次以热烈的掌声欢迎今天的所有的与会贵宾。Let us give us a round of applause to all the distinguished guests for joining us today. Now, let us please welcome the President of National Zhongxin University, President Xie, to give us a welcoming remark. 薛校长。
Ladies and gentlemen, good morning. Welcome to National Zhongxin University for a very special lecture delivered by our 10 Prize laureate, Dr. Ramanthan. And it's truly a great pleasure that you can join us for the forum. As I recall, 2 years ago, we planned to have a similar event at National Zhongxin University. Unfortunately, at that time, a typhoon hit central Taiwan, so we canceled that forum. We are very pleased that today, the weather is almost perfect. It's comfortable, it's sunshine, and we have a very special guest from UC San Diego, Dr. Ramanthan. And over the past several years, we all experienced the extreme weather and climate change. And Dr. Ramanthan spent all his lifetime dealing with greenhouse effect and also the air pollution around the globe. He was the first who discovered that hydrocarbon has a big impact and effect on the greenhouse effect. As a result of his contribution to this research field, he received 10 Prize this year. And as some of you may know, that National Zhongxin University is going to have a centennial celebration next year. So at this moment, we have the world-renowned scholar coming to our university to join us for the celebration. It's really a great pleasure and honor. And in the audience, I believe that all of you are very concerned about our globe, about the well-being of humans. So we have to work together to conquer, to combat the climate change. And with the Dr. Ramanathan's contribution, with his vision, I think we work together, we should be able to find some solution for this issue and problem. With that remark, I wish we have a fruitful and successful forum. And I wish all of you enjoy your stay at Taichung and in our university. Thank you again. Thanks.
非常谢谢薛校长。Thank you, President Xue. Now, we are very honored to invite the moderator for today is academician 刘少成院士，今天将是我们的语坛的主持人，我们热烈的掌声欢迎他。
President Xue, Tom Prize Laureate Professor Ramanathan, distinguished guests, ladies and gentlemen, good morning. I would like first introduce today's speaker, 2018 Tom Prize Laureate in development, sustainable development, Dr. I thought we have slides. We're not going to have slides? That's all right. Okay. We'll change a little bit. It's my great honor to introduce Professor Ramanathan, who we get to know each other very far back in the 1970s. I think our student, probably none of our students were born then. Professor Ramanathan has been nominated for Tom Prize and got awarded for his fundamental contribution to our understanding of sustainable development. He has contributed in a pioneer work on non-CO2 greenhouse gases, such as black carbon, ozone, and methane. In addition to that, as early as in the mid-70s, he published papers on the greenhouse effect of CFCs. As you know, CFC is harmful to the stratospheric ozone. But in addition to that, Professor Ramanathan found they also contribute significantly to the greenhouse effect. That was very original, remarkable contribution. And at that time, he was only a couple of years after his PhD degree. Professor Ramanthan was born in India, and he has also contributed substantially in helping India in the mitigation of greenhouse gases. In addition to that, he also initiated a 50-nation campaign to reduce non-CO2 greenhouse gases. I think his contribution is really extremely remarkable in the current urgent problem of climate change. And with his effort, I think we can contribute to the mitigation of the climate change problem. It's going to be a very difficult, very tough fight. In Taiwan here, we know we're having a very hard time in reducing greenhouse gases. With the help with Professor Ramanthan, I think we should try our best in Taiwan here to contribute to the reduction of greenhouse gases. Professor Ramanthan, in his work with non-CO2 greenhouse gases, I think he today will tell us some important method. His title, like in his title of his speech today, Bending the Curve. Hopefully, we can reduce the greenhouse gases. So without further delay, let's welcome today's speaker, Town Prize Laureate, Professor Ramanthan.
President of the university, and Professor Shaw Liu Chen, and distinguished members here, and fellow students. I'm truly honored to be here. So I want to thank Professor Jesse Chernow, the CEO of the Tang Foundation, for making all of this possible. I came here 10 days ago and have visited many institutions. What the memory I'll carry back with me about these last 10 days, including today, is the fact that this nation respects science and scientific achievements so much. It's just for a scientist, it brings infinite joy. As my colleague, I used to work with Shaw Liu, and I have collaborated on the issue of tropospheric ozone decades ago. I'm going to talk to you about climate change science. And First, I want to start off with a major development just in the last 5 years. That scientists are now convinced that we are experiencing new extremes, weather extremes, because we have created a new climate. This was the conclusion arrived at just last year by the American Meteorological Society, in which all climate scientists are members and all weather forecasters. So we have passed that obstacle in science. And because of this extreme events caused by climate change, the focus is now quite a bit on health effects, okay? So I'm going to talk to you about that too. So if I have to reduce what I'm going to say in one sentence, it's this, that climate change is going to reach a crisis stage in about 10 to 12 years. We're not talking about 50 years, we're not talking about 100 years, we're talking about 10 to 12 years. That's the time most of you students here, you're going to be entering your career. And I want to talk to you about how much time we have to put solutions into effect. Fortunately, there are a tremendous number of solutions. And we still have time to solve the problem. I'm just going to quickly walk through the science of it because my focus today is on the solutions. My own work is largely experimental. You know, when I left graduate school, I joined NASA, and I joined a team of about four engineers and launched this first climate satellite to directly measure the greenhouse effect of the planet, okay, and then see how the planet is changing. Later, my interest took me to air pollution, because air pollution has the same source, similar sources as climate in terms of fossil fuels. And air pollution also has a huge impact on climate. So about 10 years ago, I developed drones and miniaturized tens of instruments and started measuring how air pollution is modifying the climate. I'm not going to get into all that, so I wanted to talk to you about what's causing global warming, how bad it's going to get in the next 10 to 15 years, and what are the solutions we have. So the first major climate pollutant is carbon dioxide. When you burn fossil fuel in your scooters or buses or any industry, the fossil fuel is basically hydrocarbon. So the carbon, when you burn it with oxygen, the carbon combines with oxygen to become carbon dioxide, okay? And the problem with the carbon dioxide is roughly 50% of it stays for centuries, and 20% stays for thousands of years. So let's ask how much carbon dioxide we have emitted to the planet. 1750 is roughly the time of the start of Mr. James Watt invented this improved steam engine. So we have put 2 trillion tons of carbon dioxide. Imagine that. About 46%, that's about 920 billion tons, is still up there. Just in terms of the sheer weight, that's equal to 450 billion cars circling around the planet, okay? So this carbon dioxide then covers the planet like a blanket. How does a blanket keep you warm on a cold winter night? The blanket doesn't give you heat, it just traps your body heat. In this case, the heat from the planet is infrared radiation, and CO2 blanket traps that infrared radiation. And exactly the way the blanket keeps your body warm, this CO2 warms the planet, okay? One thing you have to remember is the greenhouse by itself is not bad. There is a natural greenhouse effect by water vapor and carbon dioxide. Without it, the planet would be frozen. So what we are doing is adding to that greenhouse effect, making the planet warmer. So until 1975, scientists thought carbon dioxide was the only greenhouse gas we need to worry about. I was a postdoc then. I stumbled onto this fact that CFC-11 and CFC-12, they were used as refrigerants and propellants, like you see from this spray can. And in 1974, the year before that, is when the famous paper by Molina and Rowland saying that CFC-11 and 12 would destroy the ozone layer. That's a chemical effect, whereas this is basic physics and quantum mechanics. And I made these estimates, and I was shocked to find that a ton of the CFC-11 and a ton of CFC-12 has the same effect as 10,000 tons of carbon dioxide. So these are now called super pollutants. Okay? After that, numerous other gases were added, and this is our current understanding of how we are heating the planet. The area under each circle is equal to the heat trapped, or the blanket thickness. Okay? So nature gave us a blanket, water vapor and carbon dioxide, and we made that blanket thicker by adding this 456 billion tons of CO2. And then we added CFCs and HFCs as refrigerants and propellants. Methane comes from leaky gas pipes, rice paddies, cattle, et cetera, et cetera. Nitrous oxide is from agriculture, and tropospheric ozone, this is the one Professor Shah Liu and I had worked together. This ozone, while it's a major pollutant in the lower atmosphere, it's also a major greenhouse gas. So the non-CO2 greenhouse gases contribute almost as much as CO2. Then came these black carbon particles. These are part of air pollution. The black smoke you see coming out of diesel trucks is black carbon. Same way when you cook barbecuing or cook with firewood, the smoke has black carbon. This does not absorb by trapping the planet's heat, it traps the sun's heat. So it absorbs the sunlight and heats the planet, okay? So we know roughly, within plus or minus 20%, how exactly we are heating the planet. How does the planet respond? That involves numerous feedback processes, which I'm not going to get into, but I'll tell you what's our current understanding of how warm the planet is going to get. So this is just to summarize for you the super pollutants. Okay? They are methane, black carbon, ozone in the troposphere, first 10 kilometers, hydrofluorocarbons. There are also super pollutants, long-lived. Their lifetime is about several decades to a century, nitrous oxide. So where do we stand? As I mentioned, as of 2010, we have already put 2 trillion tons of CO2. At the current rate we are going, in another 10 years, we would have put the 3rd trillion tons. Okay? So the planet has already warmed by a degree as of 2015. And there's nothing we can do to stop this. It's going to heat up to 1.5 degrees by 2030. It's based on the pollutants which are already up there. Okay? There is a delay. So you can say, oh, between 1 to 1.5 is just 0.5 degree. Unfortunately, that's not the way it goes. Thermodynamically, what it says is that everything we experience, extreme weather, could potentially intensify by 50% when you go from 1 to 1.5. And if society doesn't pay any attention, as of 2030, and we put the 3rd trillion ton, you're guaranteed a warming of 2 degrees another 20 years. So we got to stop this, bend the curve. The curve is going that way. We got to bend it here, okay? Starting from now. Like I said, there's still time. So I want to tell you how the field has evolved. What does a 2-degree warming mean? Just recent studies published that 1.5 billion people would be exposed to deadly heat. Just imagine that. That's almost 20% of the people planet. So we are not talking about in climate change with 10 million, 100 million. We are talking about billion and more. And this is a Max Planck Institute study. It shows 600 million additional people would be exposed to vector-borne disease. I hear that you're already experiencing increased incidence of dengue. It's all part of the vector-borne disease. Widespread droughts, and this is the thing which worries me the most. Already 20 million people are displaced, and we are talking about millions. See, displacement is you are displaced within your country. Migration is when you have to leave your country, okay? They're talking about 20 million, 50 million people have to migrate because of climate change. When you hear this, this is what's called 50% probability. But because of this feedbacks kicking in, there is a 5% probability we can exceed 3 degrees by 2050. That's just another 30 years from now. Let's see what that world looks like. This is a Princeton model simulation when the planet gets 4 degrees warmer. And this is the droughts, extreme drought. You can see most of California and Southwest. There's no chance in terms of its agriculture. You can see Southern Europe, Amazon, southern part of Africa, Australia, large part of Eastern Asia. This is 1 out of 20 models are predicting that. So you can dismiss it, saying that, oh, these are just models, you know, it's not going to happen. Look at the drought the planet has experienced in the last 5 years. The pattern is very, very similar to what is being forecast. So you can see the drought in Brazil, and I know California, we have huge fires. And you can see Southern Africa here, Australia, similarly. The question is, has that pattern already set in the future droughts? I wanted to mention to you one thing which Taiwan, you know, would be impacted, should be worried about climate change, is that your typhoons, the genesis of these typhoons, is in this Indo-Pacific warm pool. I did a major field study with aircraft and ships to understand what maintains the temperatures of this. So interestingly, typhoons are kicked up only when the water temperature exceeds 28 degrees Celsius. When you warm the planet by 2 to 3 degrees, that warm pool is going to go further north, okay? So I've been advancing this in all the universities. We need a major academic program here on typhoons, simulating them, modeling them, what does the future hold? So because of all this, WHO, World Health Organization, and the Lancet Commission has started major new studies on health impacts of climate change. So I teamed up with them and organized a meeting at the Vatican. This is our governor, Jerry Brown. This, mind you, Professor Lienza, he's also a member of this. He was at that meeting. So we concluded with unchecked climate change and air pollution, the very fabric of life on Earth, including that of humans, is at grave risk. So, and many have concluded this could pose an existential threat. So this is all of these just in the last 5 years. And I already told you that by 2030, we're going to shoot past that dangerous threshold of 1.5 degrees. So that's when you'll all be entering your career full time. Another 12 years, you'll be all 30s. So let's see what are the options available to us for solving the problem. I was fortunate to head a team of 50 faculty from all 10 campuses of the UC. Our president, Janet Napolitano, a remarkable woman, she asked me to lead this and come up with, she simply said, Ram, how do we solve this problem? So we came up with 10 solutions put under 6 clusters, okay? The first is science pathways. Science basically tells you what to do. It doesn't tell you how to do it, okay? The how to do it is covered by these clusters. I'm going to just talk to you about 3 of them. First, the science pathways. There are 4 levers you have to pull. First is to make the planet carbon neutral, basically switching your fossil fuels to renewables. I'll give you some ideas how that could be done. The second is get rid of the super pollutants. We already have technologies, right? We don't have to get rid of black carbon. We know how to get rid of NOx and others. Third is energy efficiency. That will give you, I'm showing you how much you can cool the planet by these. Energy efficiency also includes waste. We know we waste energy tremendously. So it's a nice low-hanging fruit. This lever is basically, we have all concluded, we have delayed action so much, you've got to suck that carbon out of the air. Close to 500 billion tons of CO2 has to be extracted from the air. So those are the 4 levers, okay? So let me tell you this is a model simulation, this observed record, this is the simulated temperature record. We are here, 2020. So that's where the curve is going if we ignore it. You'll reach quickly 4 degrees in another 40, 50 years. This is when you make the planet carbon neutral. Most 90% of the effort is to make the planet carbon neutral. That's not going to do anything for the first 30 years because of the huge inertia carbon has. It's like a supertanker. So to bend the curve immediately and prevent exceeding the 1.5 degrees to 2, you have to cut the super pollutants. So why are they so effective in bringing down the warming immediately? Take black carbon. Its lifetime is 1 week. So if all of us put diesel particulate filters and provide clean cooking, the poorest 3 billion who are still burning firewood and dung, that black carbon warming is gone within a month. Methane is gone within 15 years. Ozone, same. So what we need is 2 things, okay? This is like a relay race. The starter has to be the super pollutants. That starter gains some momentum and time and hands over the baton to the CO2, and the CO2 takes over, okay? So you can see how you bend it. And if you then can extract about 500 billion tons of CO2, this curve could still be kept around 1.5. So that's what I mean by there's still time, but we have to start the carbon neutrality on super pollutants now. Everything has inertia. So just preventing it from going to 2, keeping it 1.5, there's been series of studies that show that alone, the extreme heat exposure could be reduced by 1.7 billion people, just going from 2 to 1.5, okay? And then the precipitation and droughts. So there is a major benefit to people counting in billions if you keep it at 1.5 instead of letting it exceed 2. So I'll come to our solutions, okay? There's one point I should have mentioned. Let me just go back. See, the cluster of solutions is societal transformation, governance, market and regulation, technology measures, and ecosystem management. But societal transformation ranked at the top. Why is that? Because most people are still not aware of how serious this problem is. Of course, even in America, 50% say climate change is important. But if you ask them to rank it, it is 10 out of 9 other problems, okay? So we rank the societal transformation, There are 2 characters: foster a global culture of climate action through communication and education. And I want to emphasize the education. Second is we need collaboration across all parts of society, including religious leaders. So I personally have been putting this into action. So I want to give you an example of what one person can do. Hopefully that would energize you to take your own actions. So we took that report and converted it to an undergraduate course, okay? It was launched in all the campuses of the University of California system. So that hand is my tired old hand. This is yours. So my generation, we are handing over a damaged planet to you. But I don't feel too guilty because we are now providing you the tools so you can bend the curve. So our goal is to reach to 1 million climate warriors. I'm not talking about when I say warriors, go on strikes, protests, etc. No, climate change, I think many have come to this view, it's mother of all wars we have faced, more severe than World War I and II. So it has to be fought like a war. And you are the soldiers, warriors. And this course, we want to equip you the tools for solving. We've got the best experts in the 10 campus, technologists, nuclear scientists, economists, social scientists, giving lectures on the solution. So you're supposed to listen to the lecture before you come to the class, and the class is used for discussion of the solutions. So everyone is engaged. So the course now has 4 components. One is the course I mentioned, and then we are creating an online version of the course where someone can sit in this university and teach all campuses in Taiwan, okay? Provided the university has agreement to give them credits. And we have that agreement between all 10 campuses of the UC. The next part is we are creating a digital textbook to be put on online, freely available to anyone who wants to look at it. And then we are in a partnership with Coursera to create a MOOC version of it into a certificate program. So that's one. The second is, this is definitely applicable to America. You know, we have, as you know, the country has got divided. Climate change has become part of this political issue between liberals and conservatives, and we are trying to unpack it. We're trying to tell them it has nothing to do with the politics. It has nothing to do with conservatives or liberals. Climate change is a scientific issue. It's a human tragedy, and you need to do something about it. So I'm a member of the Pontifical Academy of Sciences, a group of 80 of us. A third of them are Nobel laureates. Professor Yuan Li is also a member of this. So we are trying to form this partnership, not only Christian religion, but all religions. Okay, there's a big movement in the US going on. I want to tell you, in terms of the limited success I have experienced, I invited the president of the American Evangelical Association, Reverend Leith Anderson. He heads 30,000 churches, and they are part of the conservative group, and he came to our meeting at the Vatican. And this course I talked to you about will be taught in Omaha, Nebraska, and Texas, supposed to be conservative areas. So I find it's easier to reach out to people if scientists can talk to the people directly and not through the media and all the politics. So the market regulation-based solutions are basically, of course, you need cap and trade and carbon pricing. California is running the biggest cap and trade system and participating, collaborating with China. And the second is direct regulatory measures such as rebates. In San Diego, I buy an electric car, I get a rebate from the government, okay? So it's not going to happen by itself. The government needs to help out. And that's where societal transformation comes in. You have to push the government to do it. They need support from us, okay? And I personally think universities can play a huge role in this. Let me just run through the technology-based solutions. We have estimated just the current capability in photovoltaics, wind turbines, battery, and hydrogen fuels enough to bring down the carbon by 40%, just existing technology, okay? And then we are advancing. Deep decarbonization is only possible if we electrify all the end uses, your ships, your cars, your house, okay? And the biggest obstacle in electrification through solar and wind is claimed it's intermittent. There's no sunlight in the night. How do you store the energy? What we're innovating in California is that when the sun is there, use the sun to produce hydrogen through electrolysis, and then burn the hydrogen as a fuel cell. So it's a big innovation going on. The last is the super pollutants, methane, HFCs, black carbon. This move alone, several groups have estimated, can cut down the rate of warming by half in the next 25 years. So we have a chance to protect ourselves from typhoons, from droughts, from floods. How do we do that? I must say I worked very closely with the United Nations Environmental Program and pushed them hard. At that time, head of UN Environment, Achim Steiner, teamed up with our Secretary of State, Hillary Clinton, and they formed this coalition. Now it has 61 national partners aggressively pushing emission reductions for all the super pollutants. And I was able to persuade our governor, Jerry Brown, to do the same in California. So we won't be able to, no one can drive diesel vehicles in California without diesel particulate filters. Same thing, methane. We are recovering the methane from our wastewater, from our food in landfill, and we will recover methane from manure in the farm. So this kind of a societal transformation is already happening. I think I'm running out of time. I'm going to skip these. One of the biggest sources of black carbon is cooking with biomass, firewood, dung, and solid coal. You know, we have left behind 3 billion people in the planet with 18th century technology. They have not discovered fossil fuels yet. So I started a program called Surya, providing them clean cooking. I'm excited to tell you my 2 daughters joined me in this effort. My oldest daughter, she's a wireless technologist. The biggest problem with these technologies giving into rural areas is you don't know if they're using them. People have tried for decades. And once you give the stoves, you leave the place, they don't use it. So what Nithya did is put a small sensor in each of these stoves, and she monitors them in her laboratory in Los Angeles. She's an NGO. And then we were able to recruit wealthy people in California to give them carbon credit. So the women started getting money back, and that has provided a huge incentive for them to use. So in all this climate mitigation talks, we cannot forget about the poorest 3 billion. Their carbon footprint is minuscule, less than 5%, and we know with typhoons, floods, and droughts, the poorest 3 billion could be wiped out. Same thing with methane. You know, methane is about 30 times more potent than carbon dioxide. Just aeration of the rice paddies, recovery of methane from wastewater, oil and gas, and this is the simplest thing we can do, maintain our gas pipes, okay? So finally, I want to touch on 2 things, and I'm finished. Cost. I hear wherever I go, oh, you know, taking climate change is so expensive, you know, we need to keep our industry going, etc. So let's talk about where the money is going to come from. This is an estimate by the IMF. You know, the same fossil fuels cause air pollution deaths. And fossil fuel is given subsidy of $540 billion every year, before cash subsidy. When you add that and the air pollution cost deaths, IMF estimated fossil fuel is costing us $5 trillion per year. How much do we need to change the whole infrastructure to switch to renewables? $1 trillion. And it's already costing us 5 times that. The sadness is the economists do not include externalities, these kind of damages. Okay? The other argument I want to give you is that California, 1/3 of our renewable comes from, 1/3 of our energy comes from renewables. So according to the standard arguments, California's economy should be ruined. We had the maximum growth in GDP for the last 10 years compared to any other state in the US. Third thing is, our carbon footprint is going down while the GDP is increasing. So California has managed to decouple the economy from carbon footprint. I personally think these arguments that switching to renewables would hurt the national economy, that argument is getting weaker and weaker because of these, what I call living laboratories. So the last thing I want to mention is that, see, I showed you the solutions, right? And then we in California, the academics have decided we cannot wait for the government to put this into act. We need to do it. So we have formed a coalition, and it was with the backing of our Governor, Jerry Brown, where all major universities have joined this collaboratory, Caltech, all 10 campuses of the UC, Stanford, University of Southern California. There are about 110 of us, so what are we going to do? Our motto is, German philosopher Goethe said this, knowing is not enough, you must apply. There is so much knowledge generated in academic institutions. And this, I told you, is the mother of all wars we are facing. We academics have to join the fight. It's just not enough to generate papers. We have to really apply. And then willing is not enough, you must do. So what is this coalition going to do? We are going to conduct demonstration projects on the scale of 50,000 population, speed the translation of research findings into practical solutions, and the movement of solutions to demonstration pilot projects, and then use the pilot projects. We bring in industries to take it to scale, to promote societal scale-up. So I wanted just to, as a concluding remark, I walked you through this, what I'm doing. I'm 73, so if I can do all this, you're all in the 20s, you should be able to do a lot more. And dear students, don't underestimate this problem. This is going to be the biggest issue you would face by the time you get into the marketplace. So we need millions of young people to start working on these solutions. Thank you.
非常感谢得奖者精彩的演讲。Let's all thank Dr. Ramanthan for the inspiring talk. Please be seated. We're about to start our panel discussion today. 请各位今天语坛的人士上台来。我们即将要开始我们今天的座谈会，然后由我们的刘少成院士来主持今天的座谈。
Distinguished guests, fellow students, we're going to have, I guess, 1 hour of panel discussion. And I'm very happy that we invited Professor Shen Yong, who is an expert on soil physics, also agrometeorology. We also have Professor Zhuang Bingjie, who is an expert on air pollution and also hydrometeorology. Before we start the question and answer and discussion, I would like to invite Professor Shen Yong and also Professor Zhuang Bingjie to make a short discussion. Professor Shen.
Thank you, Professor Liu and Dr. Ramanthan and Dr. Zhuang, and also the distinguished guests and all the students here. I'm really honored to be here as a panelist, and it's very lucky for me to hear the very educating speech made by Dr. Ramanthan. But I just follow your talk, then I will. Probably you don't see it on the slides. This is the slides just showing that in Taiwan, recently we also experienced a lot of those disasters caused by the extreme weathers. Say, for example, if you still recall that early in this year, we have a very long drought, and a lot of people is worrying about the shortage of the water. But in late August, the southern Taiwan experienced a very heavy, a series of heavy rainfall events, and caused a lot of those floods. And here is, you can see probably this is the historical record of the rainfall. Early in the 1940s and 50s, this is the very wet period, and this is the dry period. So this, the difference gradually the difference becomes increasing through these years. And also the very extreme drought and the wet years, they have shortened the period. Then also in January 2016, you probably still recall, we have a very severe cold spell. And at that time, even in the low elevation hills, you can even watch, you can see the snow is falling on the ground. And also the aquaculture industry, they also experience a lot of those damages. All those things, they are not right now, not yet directly related to the climate change, but this is basically follow the trends that scientists like Dr. Ramanthan mentioned to us. It's those extreme events is going to happen more frequently in the future. So those are the things we have to face. Then with this, then I think I will take this rare opportunities to raise 3 questions for Dr. Ramanthan. The first one is very simple. I'll later explain that. Then the second one is related to the climate change, the mitigation strategies in our agricultural sectors. Then the third one, it's probably not related to climate change, but I think I'd like to take advantage with all the experience you had in promoting this climate change to the society, and how do they mitigate this or reduce the CO2 emission, and then how can we convert that to improve our soil qualities? So the first one is just because you mentioned that early when you are students, you did some research, but I'm still wondering what's in the very beginning that inspired you to do those kind of research? Because I think this probably is also interest to a lot of attendants here. And this is, I think for the scientists, usually this is the very beginning, the thing that triggers you to do this research is very important. So if possible, I would like you to share this. Then for the second one, please just click the explain first. Yeah. This is basically showing the greenhouse gas emission in Taiwan. On the top left, you can see that most of the CO2 emission is from energy department. Agriculture only takes about, okay, let's see, where is this? Agriculture only represents only about 1% in Taiwan, the non-greenhouse emission. And from those greenhouse emitted from the agricultural sector, the CH4 and the nitrous oxide, you mentioned the sulfur pollutant, those are the 2 major sources. CH4 represents roughly about 47%, and nitrous oxide represents about a little bit more than 50%. Then those CH4, about 40% is from paddy rice. Then the rest, about 60%, is from animal productions. Okay. Then the nitrous oxide emission mostly, as you mentioned, is from fertilizers. We use a lot of those fertilizers, and those fertilizers, they not only produce those nitrous oxide to the atmosphere and also pollute our environment. So as you know, our university is the leading agriculture university in Taiwan. So I think a lot of our faculties here, and probably in the future, the students, they probably like to know what would be your suggestion that what we can do to make some contribution in agriculture sector to help to reduce the CO2 emissions. Could you click the back? Okay. Then the third one is, as I mentioned, this how do we improve, or let our general public aware that soil is important. Because soil, just like air and water, soil actually produces about 95% of our human needs. But we know that when you experience a bad air or bad water, then you know that immediately. So you will put some actions to correct that. But soils, a lot of people don't aware that the soils is gradually degraded by our human actions. And so the United Nations, they announced, could you click that, explain? Yeah, so the United Nations, they announced that in 2015, there's an International Year of Soils. So yeah, they try to let all the governments around the world to promote let their public to aware the importance of maintaining the soil. And our local soil scientists also do quite a lot. Other than those academic meetings, we say, for example, we encourage students, say, we have a soil exhibition car, so we can travel around Taiwan and let the public know the important function of the soils. And we also publish a lot of, some of those magazines in public magazines, so let people know. And recently, actually this spent 3 years, we just made a movie that we call it The Story of the Soils. And it just got nominated for the 2018 Golden Bell Award. And in the next 2 weeks later, the Saturday, they will announce the final results. Hopefully we will win. Okay, so those are the things we try to do. But I just wondering, based on your experience, could you, give us some suggestions about what we can do to let our government, general publics, or the students, know how to maintaining the soil in good quality is very important. Yeah, please share your thoughts. Thank you.
Thank you, Professor Zhuang.
Thank you. Okay, so thank you, Ramanthan, for you coming here. Okay. And really welcome you. Yeah, I know this time we have two laureates. Oh, sorry, how to push it? No, don't work out? Okay. Okay, I see. Another laureate is Mr. Hansen. But then he came with you. And I remember we see some big news about he go to some nuclear power referendum. We are going to help maybe 2 months from now. So asking him to stand out to speak for nuclear energy. So actually I kind of feel offensive because we have been trying for so long. We have decided to phase out nuclear energy by 2025. I will just put it in law this year. So when this action a little bit make me angry. Yeah. So I know very clearly that nuclear generation is true. From the Hansen ESTN paper, he saved millions of lives. I totally agree because I do the air quality study, and we found all the coal power plant, the near power plant, we have severe air pollution problem even in here. And we had largest power plant. It was a large power plant in here. So I'm not totally clear about the cause. But we know, life is very important. But habitats is very, very important as well. Sometimes more important than lives. many scientists do lots of simulation. We found if the nuclear meltdown at the Fukushima meltdown level, then half of the habitat in Taiwan will be lost. So when it lost, you know it will be gone for at least 30 years. So it's another issue between life and habitats. So we actually feel very, just very grateful. Finally, we decide to phase out the nuclear power plant. But of course, we understand another issue you just raised. The climate change is a very, very important issue. We totally understand. And actually, I've been in UCLA, I do the climate simulation. I go to GFDL. I also go to the Max plant. So I do all these models, and I know very clearly. And in the government right now, we are also tried very hard. We phase out the nuclear power plant, and also we try to reduce the carbon dioxide emission from coal power plants. So we say we have a goal to reduce coal power plant from currently about 46% power generated from coal, but it will be reduced to 30% by 2025. And we do all the calculation, we found in 2030, then carbon dioxide can be reduced by 20%. But still, it's not carbon neutral, as you mentioned. So we are still thinking how to reduce further to 50%. So we are thinking other ways, not nuclear. But I know I'm very glad to hear from your speech. You say there are 10 other methods, right? 10 other, and also I asked my student in environmental engineering, I asked him from the front door of our university and go to our department near the back door, how he go there. He say he ride by motorcycle. Just go to Nanmenru and Tinzai and park in our rear gate. So I'm asking you, you are environmental student, why don't you walk or ride by bike? I know it's very difficult for him. So I know it's happening here, even in this room. As many students, they ride motorcycle, right, all the time. So there are many, many ways, but it's a very tough issue, I understand. So for example, last year, we are the first time during the very haze polluted day. It's like PM 2.5 is more than 54. And you can see from the back, if only 40, you cannot see the mountain nearby. But if below 30 or 15, then you can see the mountain. So starting from last year, the last fall, and every time the EPA forecast there are going to be haze days, then the power generated from the natural gas had higher priority to generate power. So by that policy, now the haze day have been reduced by half. So we think we are doing small things, but these arguments, sometimes many scientists in Taiwan don't think the power plant caused these haze days. We are still arguing. But luckily, this March, a professor in academic Sinica, Zhou Chongguang, he did some research. He put some tracer on Taichung power plant, also minor power plant. He found this tracer really go into the mountainside. So I think we are doing the right track, but we are just doing things very little by very little. It's still very hard. So my question is, could you give me some of the students some advice for handling many controversial issues regarding to environmental, energy, and equality? I think that's a very, very difficult issue. Thank you.
Thank you, Professor Zhuang and Professor Shen. Professor Ramanthan, you probably got the message here. In Taiwan, I think in Taiwan with the education that's very education of the population is very good, extremely, I think, leading the world in that sense. And the citizens in Taiwan are well aware that we needed to cut CO2 and other greenhouse gases. But in Taiwan, we tried for, I think, at least the last 20 years, we talk about it, and nothing was done. Because you can see in the Professor Shen's emission is flat. Last 10 years, there's no reduction. We are willing, we like you quote the God philosopher say, willing is good, but you must do, okay? We're willing, but we haven't done. So that's the question.
Can you hear me? Yeah, very good. I'll start with the first question. What inspired you in the very beginning that led to all those very important findings? This is particularly to all you students. I was not a very good student in high school. I was sort of average in college. So don't be influenced by what you did in your high school or college. There is still a bright future. And to me, the lesson I learned is that if you take the time to find out what you are good at, then you will reach your full potentials. I did engineering. I hated engineering. And somehow, because my parents told me I did engineering. And I tried various things for 5 years before I accidentally found I was good in research. I was not good in following others. I was good in following my own path. And so that's something you have to find what you are good at. But most of my research findings are basically true for all the faculty scientists here, but just intellectual curiosity. And I never realized till I turned 60 that I was just bringing bad news one after the other. Pollution did this in India, global warming did this in India. So it was only after I turned 60, I joined the Vatican Academy of Sciences. I realized climate change is becoming a huge human tragedy. So I switched my work from science to go into solutions. So that I hope I answered your question there. I think, one other thing I didn't mention in my solutions, I had the sixth cluster, ecosystem management. In California, in our collaborative, my co-chair is working on agriculture. There is a huge potential there to store that carbon by better agriculture practices and in the soil. Soil carbon content, potential content is so huge. I think the current estimate is you can almost take about 5 billion tons every year and put it into the soil. So I don't know all the details. Since this university is expert in agriculture science, that's one thing you can explore. I was personally surprised to find Taiwan is still using coal. There's one thing to explore is that can you offset the carbon emission from the coal by storing that carbon in the soil? So there's a tremendous potential there. I can connect you with scientists in California, our UC system, who's working on this. And I think the third question was, how do we let government officials and general public in Taiwan realize that we need to protect our soils in good qualities? The same question was raised when I gave a talk at National Taiwan University and then in Tainan yesterday. I feel the time is ripe now for major universities in Taiwan to get together and the academics, come with list of priorities to the government. You see, in the US, our National Academy of Science does that. The National Academy of Science will commission various academics and we release reports. And I was told the academic syndicate doesn't do that. Maybe you can comment on that. But I certainly think there is so much amazing research going on in universities. But this solution to this problem is much bigger than a university or much bigger than even group of universities. And we in California learned just teaming up with the 10 universities. Our voice was huge. We could talk to our governor. So that's something worth exploring because this is just not a problem of agriculture. This is just not a problem of technology. It's just not a problem. It's everything, all of that put together. And I personally think societal transformation is a huge part. And that is where the young people, you can really help us because you have the social media, right? Communicate the urgency of climate change. But then to do that communication, you have to learn about climate change. You have to be able to tell your parents, your relatives, your friends, that climate change is based on sound science, and the climate change problem is going to get into a crisis stage in 10 years. We still have time to solve the problem, but we need the government support. So in that sense, yeah, I think there's a huge potential there for the general public. If there's anything I left out, I'll be glad to answer it.
Professor Zhuang's question, I think, basically is nuclear.
Right.
Is controversial here, and
I think it's controversial everywhere. In California, in our 10 solutions, we had 2 top nuclear experts. And we couldn't agree, so we didn't bring up nuclear in a big way in our 10 solutions. And for example, California has banned nuclear power plants, just like Taiwan did. And as you know, Germany has taken a similar position. But the experts I talked to, I said, oh, the new technologies are much safer. So nuclear has an image problem first. It has not been, I think the nuclear experts have not been successful in persuading the public. No, we have safer technologies. But I think what I would argue there, I am neutral on that, on the nuclear technologies, but I'm living 90 miles south of this San Onofre plant in Long Beach, which was shut down a year and a half ago. And nobody wants our waste, so our waste is buried just 5 meters below in the beach. But I think the climate change, when it reaches crisis stage, when you are going to be hit with what we call Category 5 typhoons, then is that danger more than the dangers of nuclear? So I think careful risk analysis has to be done, and then maybe we'll come to the conclusion nuclear is not that bad. But such a study has not been done yet.
Thank you, Professor Ramanthan. At this moment, we still have about 40 minutes left. I would like to invite, in particular, students and, of course, faculty members too to ask questions or making comments on this very important problem, particularly for Taiwan. We're facing with such a difficult time, both in terms of the effect, extreme weather in Taiwan, and also we are under the pressure politically, economically, international pressure to reduce greenhouse gases. And we do want to do that, but we haven't done anything. So, please.
同学们，如果您有问题的话，也可以用中文来提问，中英文都可以。那我相信在座的专家都很乐意帮你们翻译。
Yeah, you can ask in 可以用中文讲 ，ask in Chinese. Somebody will translate for you.
尤其是刚刚讲者特别提到传承的问题，所以我们希望年轻的学子们能够投入永续发展这一个领域。
All right. Pardon me. Well, you see, just now I have noticed that you have mentioned Dr. How may I address Dr. Ramanathan?
Ramanathan.
Yes, thank you. That I
Just
noticed
call
that
him Ram. R-A-M, Ram. Yeah.
Yes, I copy. Yeah, Dr. Ramanathan. Yes, that I noticed that there has been an absence of the address of banking, finance, and petrochemicals. As you can see that recently that the World Bank has announced a withdrawal of investment in the petrol industry, correct? And that perhaps, would you like to comment on a few occasions on this? That would be all.
Yes. No. One at a time. Yeah. No. This is, they have the option to ask in Chinese, but he preferred to in English. So.
No. I beg your pardon because I'm more fluent in English. I'm just a little nervous right now.
Yes, fine. We understand your problem. Yeah.
Yeah. I think that the thing you mentioned, divestment of fossil fuel, is an important step. Major investment, institutions can take. In America, a lot of the capital is in retirement funds. But I think those are all going to take time to take into effect. I personally would prefer the approach where we bring in the commercial institutions, including fossil fuel companies, if they would agree to do that, as part of the solution, okay? So for example, I'll tell you, I'm working with the group, the Canadian energy industry. They're involved in shale. And the chairman of that multi-billion-dollar institution visited me in my lab, and I talked to him about climate change. And they asked me at the end of it in a very interesting question. They said, how much time do we have? So I told him 10 years. And so why did I say the fossil fuel companies has about 10 years to switch to other things like renewables or switch their business practices? Simply because I think, you see, just take the California example. Just in the last 7 years, we've had these droughts, and that has made the whole ecosystem susceptible. Our trees and houses are going in flames. So that has provided the motivation and the incentive for our governor and politicians to pass aggressive climate mitigation laws. Just 10 days ago, our Governor Jerry Brown had this climate summit where California passed a law, SB 100, it's called Senate Bill 100, where we will become completely carbon neutral by 2045. And that's a big step because California, very few realizes, is the second or third largest producer of oil and gas in the US, okay? So like that, I'm fairly convinced that when we go from 1 to 1.5 degrees, where we are talking about heat waves exposing 1.5 billion people, there will be a huge cry from the public to take actions, just like in California we have. I'm sure it'll come in Taiwan because you saw this nation is sleeping next to a gorilla, right? That Western Pacific warm pool is the most dangerous gorilla you can think of. And you heat that ocean. I don't trust any models in simulate that. Okay, this highly turbulent, nonlinear flow. So I know in 10 years, it'll become dangerous. It'll be in everyone's living room. And I think that is where people of your age, you need to prepare yourself. You prepare yourself by you are in this fantastic universities, getting knowledge about climate change and finding out what you can do. And, you know, divesting from fossil fuels and all that, or strikes, is okay if that makes you happy, but they are not part of the solution. To me, the solution is take this society to the next stage. What is that next stage? Don't produce waste. That when you burn fossil fuel, I showed you, you have produced 2 trillion tons of waste. And 450 billion of that human waste is in this air. So we have to become waste-free society. And the only way I can think of doing that is switching to sun. It has infinite power. Use that sun to produce hydrogen and burn the hydrogen. So you see, you take water, hit it with sunlight, water becomes hydrogen. And when you burn it, hydrogen combines with oxygen, becomes water. And I am very close colleague, friend of a billionaire in California. He has this, you know, huge estate of wine producer. He does farming. That entire area is done this way. He is off the grid. When there were fires, his house was the only house, his farm didn't get onto fire. And in this collaborative, we are going to test this hydrogen idea. But you know, maybe you have your own ideas. I think every solution has to be localized. What we do in California may not be appropriate here. So I'm not too optimistic. I know if you look at the American situation, we are running backwards in taking care of climate change. But it's going to change in 10 years. The problem is going to get 50% more serious. The issue then is, are you ready when it hits us to come up with solutions?
Thank you. More questions? There, in the back.
各位老师，各位先进，你们好。我是环境专业和都市专业的这个硕士生。有一个问题，我问过了非常多的政治人物，也问过了很多的规划师，包括了欧洲规划师。那这个问题是说， 都市绿化可以帮助我们调节这个都市的微气候，那也可以带来更多的这个效益，然后也对城市永续发展是有一个帮助的。但是相对的，我们也发现都市绿化越做越多，会提高都市的地价，造成社会上的一种不平等，然后拉大都市之间的隔阂。所以这个问题应该是要问说，我们要怎么样去拿捏永续发展，还有这个城市绿化，还有以及这个社会问题中间的一个平衡点。谢谢。
The question is, urban development affect of course, property price and the environment, also urban heat island, these kind of problem. And his question is how do we deal with urban development in terms of the greening of urban environment, and how do you balance the urban countryside, the economic imbalance there?
That may be a little bit on the economic side, beyond my expertise, but it's a good question because remember, more and more people are going to leave rural areas and crowd into big cities. And climate change is going to make it worse because you saw my map. If 40% of the area is going to be subject to drought, so the rural people have to come to the cities. I'll tell you what's happening in Los Angeles and in some of the Californian cities to deal with this urban heat island issue. Two things. They're starting what's called urban forestry, rooftop plants and plant trees. And the second is what we call cool roofs. You can paint your roofs with reflective material so they reflect the sunlight back. And there are many such solutions being taught to deal with the urban problem because we are already feeling the heat. Los Angeles is ready to go on flames with heat waves, droughts, and the urban heat island. And I'm not completely familiar with all of the solutions, but I know the ones we are thinking of is urban forestry and cool rooftops.
Any more questions? There, 53 number.
各位教授好，我想问一下，就是 Ramanthan 教授，就是有关于，在美国的部分的话，我们都知道，对，在今年，前几年就是川普他退出了巴黎气候协定，那还有一些像是台湾，就是政府因为核能的问题而重启一些低效能的火电厂，来达到一个就是所谓的去核的一些政策。那我们都知道这些政策性的一些转变，就是造成了一些我们在就是环境二氧化碳的减量的部分是开倒车的。那怎么去避免像是这种因为政府性的一些左右的政策的那些行为，去造成我们这些推动二氧化碳减量的那些作业，就是没有那么大的成效，就是可能如何去避免政府的那些错误的决策造成一些我们在二氧化碳的减量上面的一些成就。谢谢。
Actually, in Taiwan, nuclear energy was supposed to help with cutting down CO2 emission, but with the government indecision in the nuclear policy, there's this problem, how can you solve it? But you already addressed earlier a little bit, but yeah.
You know, I think the California example would be a good one. So I'm wondering if some professors from universities here try to study how did California do that. I simply unable to understand why Taiwan can't use solar. Wind is a problem. In the subtropics, you don't have strong winds except during typhoons. We are, you know, I live in San Diego, right? And our mayor is Republican. But he has the most aggressive laws because we have found out solar is cheaper. See, I have solar on my rooftop. I put it 7 years ago when solar was still expensive. I recovered my cost in 6 years, and now I'm making money because I don't pay any electricity, and my neighbor is paying $1,400 a year. So, but I don't want to blindly make a statement, oh, Taiwan should go solar. But I have not heard a convincing case why solar won't work here. The problem with solar is storage, right? You know, when you have clouds, you don't have sunlight, or when you have nighttime. But we can store that sunlight in hydrogen. You know, Toyota now has cars, Honda has hydrogen cars and buses. And Germany 2 weeks ago, it was in your Taipei Times day before yesterday. Germany has a train running on hydrogen. And Taiwan is so advanced. You know, I think you produce the largest amount of ICs, integrated circuits, in this country. So I'm unable to connect that part of Taiwan with the part which wants to go coal. Because coal is the worst of all alternatives. It kills people, right? Air pollution. It is damaging to climate. There is just no redeeming qualities about coal. Nuclear issue, I don't think I will critique the government because nuclear has this image problem with the public. After all, we have to do what the public wants. If the public doesn't want nuclear in their backyard, so I can understand why the government is, why the policy is shying away from nuclear. In California did this. But I'm not saying I buy the argument because nuclear could be made safer, but ultimately the public matters more. If they don't want nuclear, the government, there's no way they can go nuclear. But I think somebody has to study, some academics here, how come California's GDP grew by 46%, highest in the nation, US, in the last 12 years, while our emissions went down and our renewables went up. So that needs to be studied. I think Sweden is similar, but what happened in Sweden is that they exported some of their manufacturing outside, so that carbon footprint is not counted on them. But Sweden's economy also got decoupled. Their GDP went up, their emissions came down. So this argument that going to renewable is going to destroy the economy is not being supported by examples. So I would be careful about pushing nuclear very hard. I think the people don't want it. I don't want this on my backyard. And I'm educated. So I would push for bringing down the emissions. If it turns out people accept nuclear, fine, put nuclear. But that's not the only option.
Thank you. Here, I think Professor Ramanthan pointed out one critical problem. I think You know, I like to use a very simple example to say what the problem in Taiwan we're facing with. There's a very easy way to cut down CO2 emission. That is, you put carbon tax, raise carbon tax to a certain level. If the population really believe we need to cut CO2, then we should be willing to pay more carbon tax. Once you get carbon tax, it automatically going to manifest in private entrepreneurs. They'll find a way to cut CO2 emission. However, in Taiwan, as well as, I'm not blaming Taiwan, in many other countries also, carbon tax, once the government say, I want to increase carbon tax or implement carbon tax, then the government is done. People voted down because it's extra tax. They don't see benefit. That's a problem. Please. 89.
教授们好，我来自于这个国高中的这个公民社会老师。那我做了20几年的环保志工。那我觉得我们是地球的一份子，每一个人都要做这个事情，而且很重要。就是说，我们每一天制造的垃圾能够去资源回收，包括塑胶袋，包括保丽龙。那我一再强调说，保丽龙其实是有带药性的。如果说你燃烧之后有带药性，它是会致癌的。所以呢，我会希望学生也能够一起来。那虽然政府有在回收保丽龙，可是事实上到现在，我昨天才知道说，我的阿姨她住在东区，台中市的东区，她说她保丽龙要去资源回收，资源回收车的人等下讲说不可以，她说你就直接丢到垃圾车里头了。那所以同样的，在台中这边的那个，就是台中资讯图书馆这边的话，也有一家那个厨具店。那老板娘把那个保丽龙的话，也是一样丢在外面，我都跟她讲说这个有在回收哦。她说真的哦，我说你一定要在这个资源回收车里头丢进去这样子。所以呢，我认为啦，我就说我们地球的一份子，所以每一个人真的要把自己制造出来的垃圾好好的做好资源回收。好，这是我希望我们大家一起来，是这样子，可以吗？
Essentially saying recycle is very important, but people apparently haven't done enough. Have not done enough with recycling, especially with plastic.
Yeah, that's an excellent point. I'll tell you one example in terms of recycling. We throw away 40% of the food in developed economies. I don't know about Taiwan, certainly in America. And in developing nations, 1/3 of the food is thrown away. So we take the food from the garbage cans and put it in landfill. What happens is that food degrades and produces methane, 30 times more potent than carbon. So now we are in San Diego, we started a zero waste program where that food, the landfill, they convert it into methane and burn it as biogas. One idea I'm pushing, so far I've not been completely successful, that instead of going to the landfill and recovering that methane, we provide a biodigester, at least the minimum all restaurants and food stores. So when the food is rotten, they throw into the biodigester. It produces methane and then use it as fuel, natural gas. So there are this lot of low-hanging fruits And just imagine 40% of the agriculture is thrown away. Imagine the carbon footprint of that, the methane. And so I agree with you. Recycling is a good place to start thinking about reducing our carbon footprint.
64号。
Thank you. Sorry to trouble you again. I've got another rather question and comment on this. First of all, carbon tax. In the term of carbon tax, you see why people do not, general public do not support it, is that, no incentive. So, like for example, the tax, where you use something that generates carbon dioxide and you pay for it, basically. But then if you reduce it, so you're not getting any returns from that. Yes. Where it's been seen in case in Taiwan, I've heard before that for traffic offenses, like for example, you make an offense, you pay for it. You get penalized, some $100,000, whatever. Yes, but if you are a law-abiding motorist for maybe a year or two, you can prove it. And there is something called a environmental tax. Well, Taiwan already has that. And then it's more directed on keeping the roads safe. Yes, but they call it something like a combustion tax, something like that, yes. And I've heard people talking about it and saying that there should be an exemption. So you have obeyed laws, you have traveled safely for a year or two, you fulfilled that requirement, now you're exempted from that tax. Yes. That one is an exemption, but what you have mentioned previously on this case, where you have the, I've seen this project Surya. It's, I've seen it on YouTube where when I was trying to play with rocket stoves, I like to play with things.
Quiet 一点。快一点。
Oh, sorry. That would be all. Thank you.
你问题是什么？ What is the question?
My question would be in this carbon tax. Well, let it be a comment then. Yeah.
Essentially, his commenting carbon tax doesn't work. But a carbon tax works in a lot of countries very well.
Yes, perhaps it works like in China. Thank you.
后面。
我想请问一下，就是刚才教授有提到说，台湾普遍通勤的习惯还是用汽机车这一种化石燃料的发动的为主。可是我知道台湾政府其实现在有在推动用电动车的方式去通勤。那在台湾想要废核，可是现在绿能发电还没有发展到很完善的状况下面，我们只能依赖火力发电。这样子的状况对于碳排放的问题能有改善吗？因为电动车也是用电，我们电的来源是火力发电。那这样子，我们推广电动车是不是能造成排碳量减少的效果？谢谢。
That's a good question. Says electric cars, if the electric energy is coming from fossil fuel production, producing power.
No, that's, as you said, that's an excellent question. For example, I see in California, particularly San Francisco, electric buses, they say it's zero emission vehicle. But if that electricity is produced by coal and natural gas, it's really not zero emission. It's probably zero emission for air pollution locally. So electric cars by themselves is not the complete solution. So the electric cars cut down both air pollution and climate pollution if that electricity is generated by renewables. Yeah, I agree with you.
More question? Yes. 69号.
Good morning, professors. And I'm a student studying in a nearby college. And recently, the other 4 students and I have established a school club which aims to protect the environment. And may I ask if you have any suggestion on what we can do if we want to help solving the problem of climate change? Thank you very much.
I didn't quite get the, can you repeat it again?
Okay. I and several students recently started up an environmental club which aims to protect the environment. And may I ask if you have any suggestions on how we can help solving this problem?
Yeah, I mean, that's again, I'm asked that question frequently. And you can reduce your own carbon footprint in a number of ways. But I know people of your age group, you're very busy with your studies, thinking about your future. So it depends on how much time you're willing to put to the problem. But if you can do only one thing, that one thing has to be spreading the message. See, very few people, I would say even in the US, are aware this climate change problem has become a big gorilla. And it's not 100 years from now, it's 10 years from now. So I think the biggest help you can give is using the social media to spread the word. But spreading the word does not mean simply say, oh, you know, we cut this, we become. It has to have information. So I think I heard that you have formed a group in your college. That's fantastic. And then you can use that group power to each one get educated on the problem, right? Why is climate changing? What is it going to happen? What is the science behind it? And then what's the future? And then you use the social media to spread the message, right? Then people can participate effectively when issues such as should we go nuclear, or should we go coal, should we go natural gas? So I think that education of the public, that includes your parents, your relatives, your friends, on the urgency of the situation. The typhoon situation is not going to get better. It's just going to get worse and worse and worse. And that's the urgency. If you can communicate, you would have done the biggest service. You see, if you had asked me this question 20 years ago, I would have said, reduce your carbon footprint. Set an example. But now it's too late for all that. We need top-down actions. So the top-down actions is going to happen only when we have bottom-up support.
Okay, we have time for only one more question. And there's a young lady raised her hand for a long time. And please, 请。
老师好，因为我听不懂英文，所以我是用中文发问。这不是问题，就是我个人的想法，就是说呢，现在台湾的空气污染很严重，但是已经 有解决这个问题的办法，就是说有一个美国的科学家，他发明了一台非常庞大的机器，就是可以把所有的 PM2.5的粒子都压缩在一起，变成一个钻石。那这是一个解决办法。那全球暖化的话，我们只要把热能排出去就可以。热能的话呢，美国的科学家开发出了一种特殊的薄膜，可以把热能转化成特殊的射线，把它发射到宇宙去，可以有非常有效的降低温度。那温室气体的话呢，我们可以研究历史上几万年前、几亿年前，或者是几十年前，为什么温度会降低？为什么会升高？是否出现了什么样的特殊的气体？那这些气体是不是可以帮地球降温？如果说我们找出这种气体，给它大量的排放，或许可以综合温室效应。这是我的想法，谢谢。
你以后一定会是一个很好的科学家。She asked some very interesting question. She said the traditional air pollutants, now we have various ways to solve them. And one of them was packing all the PM 2.5 into some kind of bricks and throw away, bury it. And of course you heard that. And there must be other ways for greenhouse gases and heat to reflect or somehow to solve the problem.
Yeah, excellent question. There are two things we can do, just like the example you gave for air pollution. You can grow marine organisms which can take the CO2, carbon dioxide, from the air, algae and bacteria, and they're being looked into. Basically suck that carbon out of the air and bury it deep. You asked about, is this something we can do about the warmings? Some people are talking about putting mirrors in space which reflect the sunlight. And others are saying we can put air pollution particles which will reflect sunlight, sulfur particles. They're not going to solve one of the real problems with carbon pollution. The carbon dioxide, about a third of it is taken by the ocean and makes the ocean acidic. And that will make it difficult for the food chain in the ocean to thrive. So we just have to take the carbon out of the air. And we just have to stop putting more carbon into the air. It's not only heating the planet, it's also destroying the marine ecosystem.
Thank you. We are running out of time, and it's a very good discussion session. I'd like to take this opportunity to thank Professor Ramanathan and also two local experts, Professor Shen and Professor Zhuang. And of course, thank you for coming for a very exciting session.
Let us give a round of applause to thank all the panelists today to give us an inspirational discussion. 请各位先稍留步，我们会邀请贵宾们跟大家合照。首先，我们先请在本校的老师长们到台上来做一个合照。We are going to have a photo session first. 等一下会请贵宾到台下与同学们合照。好的。All the information for today, including the PowerPoint of the speakers, will be posted on the website of the 10th Prize. 那我们是不是请学校的老师们上台来，我们做一个合照？ 请各位贵宾先回座。We're going to have a good photo with the students and guests. 想要跟大师们合照的同学，欢迎大家到前面来。我们会从这个角度拍过去，对。好的，非常感谢。我们今天的活动呢，就在这边。我想，永续是大家每个地球公民的责任。那也很感谢今天与会的来宾们，谢谢大家。